Hi friends, welcome back to my YouTube channel. Today I am going to discuss about data link layer. This is from the module 2 computer communication ECE 407. So this is based on KTU syllabus. So let's go to the video. So this is the introduction. So before we have already discussed about physical layer and types of transmission, everything we have discussed in the first module. So today we are going to start our second module topic, data link layer. So data link layer have two main functions. One is data link control and second one is media access control, MAC. So MAC and DLL. So MAC is a function that is discussing how to share the link between these two nodes, and data link control deals with the design and procedures for communication between two adjacent nodes. That means node to node communication. So in this figure you can see there is two nodes are there and there is one link between these two nodes. So DLL is doing what? It's a design and procedures for the communication between two adjacent nodes, and MAC is defining how to share the link between these two nodes. So these are two connected, and we are mostly discussing here more about DLL, data link layer, and its functions. So data link layer also have the functions like framing, flow control and error control, and it's a control, the functions of data link layer is the framing and flow control and error control. So if you see in the physical layer, these data is passing like bits of data as a sequence, it's a pulse, or it's flowing like a bit of data from physical layer in physical layer and between destination to sender to destination. So here what we are doing to implement the DLL, we need protocol, and this protocol needs to be implemented in software and run by two nodes that involved in the DLL. So what we are going to do, we are going to discuss about the framing part. So the bits of data that we need to change that into frames to send it to upper layers. So from data link layer to the upper layers, we need to change it as the bits of data into frames of data. So that we are going to discuss next. So the main way of changing the bits of data into frame is framing. So data transmission in the physical layer means moving bits in the form of signals from source to destination, and physical layer provides a synchronization to ensure that the sender and the receiver use the same bit of duration and timing. So this is the main part that what we are doing in physical layer, that we are providing a synchronization bit, and it ensures that the sender and receiver use the same bit of duration and timing. So DLL needs to pack bits into frames so that each frame is distinguishable from another. So these bits they are changing into frames, packing it as frames, and this frame needs to be distinguishable from one another. So if you see our postal system, whenever we are sending a letter to another person, we are taking the letter and we are putting it in an envelope and writing our address and the sender receiver address, and they will acknowledge when they receive the letter. So that is a process. So in the same process that we are doing in framing. So framing is the way that the DLL separate a message from one source to destination or other message from other destinations by adding a sender address and a destination address. So framing, first of all, the DLL separate the message from one messages and another messages and sender or receiver, the different destination, by adding the sender address in the destination address. So the sender help the recipient to acknowledge the receipt, and destination address defines where the packet is to go. And although the whole message can be packed in one frame, but we are not actually doing that, since the frame can be very large and making the flow control and error control be very inefficient. So we can also send the frames as a large, instead of dividing into small we can send it, but there is a problem like its error control and its flow control will be very inefficient. Like it is very bad if it occurs an error in between in a single bit of that large frame. We need to retransmit the whole message once again. So this will take time and it will make many problems, and data integrity will be also affected. So we cannot send the data as a large frame. For that we need to divide these into small frames, and this could reduce the single bit error, only affect the small frame, since we are dividing the large frame into small frames. So we can done this in two ways, that dividing the frames into smaller frames, we can do it in two ways. First one is fixed size framing, and second one is variable size framing. So in fixed size framing, the name itself, it's saying that it's a fixed, so we don't need to define the boundaries of the frame, that we don't need to define the delimiter. So for this example, the ATM wide area network, so we are using a frame of fixed size called cells. This is an example for fixed size framing. So next one is variable size framing. So variable size framing, the name itself, it is saying that it's variable, the frame of data is variable, and in this case we need to define the end of the frame and the beginning of the next frame. So we need to distinguish with the frames, two frames, so we need to define the end of one frame and the beginning of the next frame. So to do this activity, we have two approaches in variable size framing. First one is character oriented approach, and second one is bit oriented approach. So character oriented framing means we are sending the data in 8-bit characters, and the header, there is header and we have one trailer, and the header consists of the data that needs to be carried to the destination address and the sender source address and some control information it carries, and trailer which carries the error detection redundant bits, and it's also 8-bit, also of 8 bits. And here, to separate one frame from the next 8-bit, that means 1 byte flag is added beginning and end of the frame. So the first condition, why we are using this byte framing and this bit framing, byte oriented approach and bit oriented approach, we need to separate the end of the frame and beginning of the next frame one to another. So that's why we are using it. So to separate one frame from another, we are using a flag which is added at the beginning and end of the frame. So in the figure you can see there is one flag added at the beginning and end of the frame, and there is header and trailer in between the data from the upper layer. So the character oriented framing was popular when the text was exchanged by the data link layer, and the flag could be selected to be any character that is not used for the text communication. So the main thing is that the flag cannot be in the data that we are sending from source destination. So this will make an issue if the data having the same pattern of that flag, that we are discussing next. So if the data is having the same pattern as flag, then the receiver encounters that the pattern in the middle of the data, think it is the end of the frame. So this will make an issue. So to avoid this issue, we are using the byte stuffing strategy. So what we are doing in byte stuffing, we are adding an extra byte in the section of the frame when there is a frame or character with the same pattern, that is the flag. So when we are seeing a pattern that is same as the flag, we are adding an extra byte after where we are seeing the data, where we are seeing the extra data that we are sending. So the data section is stuffed with an extra byte. So this byte is called escape character and has a predefined bit of pattern. So whenever the receiver encounters the escape character, it removes it from the data section and treats the next character as data and not as a delimiting flag. So this is the way they are reducing or fixing this problem by byte stuffing. So byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. So they are adding one extra byte whenever there is a flag or escape character in the text. So byte stuffing by the escape character allows the presence of the flag in the data section of the frame, but it creates another problem. So this also leads to another problem, like if the data having two escape character, what does it mean? So once it is an escape character, that means it is not the end of the frame. But if they see the next escape character, what it will see, what will it play, it will take it as a end of the frame, so it will make a problem. So what they are doing is they are adding one extra bit after the second escape character. So this way they are reducing, but this is not a proper way. They are creating another issues also. So this leads to another approach called bit oriented protocol. So bit oriented protocol, that is we are discussing next. So before that we need to discuss this figure, because it is very important when we are writing the exam. We need to put the data as well this figure. The figure having much value than the data that we are information that we are putting in the answer sheet. So please remember that to not forget to put this figure in the answer sheet. This is very important. If you are having a 10-mark question or 5-mark question, it is better if we are putting this figure in the answer sheet. You will get more marks than the others. So from this figure we have seen that they are stuffing the escape character from the in the send frame, and after sending they are unstuffing this escape character and sending it the normal data. So this is the figure for byte stuffing and unstuffing. So the next one, so we already saw that some issues in the byte oriented protocol, we are changed that to bit oriented protocol. That means, so we are now discussing about bit oriented framing. So in bit oriented framing, one data section of the frame is a sequence of bits to be interpreted by the upper layer as text, graphics, audio and video, so on. So however, in addition to header or trailer, we still need a delimiter to separate one frame another. So in this case, we are using the flag as a 8-bit pattern. The flag is 0 1 1 1 1 0, so as a delimiter to define the beginning and end of the frame. There in byte oriented protocol we used one extra byte or 8-bit data, that is as a flag, but here we are using 8-bit pattern as a flag. So this 8-bit stuffing is the process of adding one extra 0 whenever 5 consecutive ones follow a 0 in the data. So what we are doing, we are adding an extra 0 whenever we see 0 and 5 ones, so that the receiver does not mistake the pattern 0 1 1 1 1 0 for a flag. So this flag can create the same type of problem we saw in the character oriented protocol. So if the data having the same pattern as the flag, then there is a problem. So to avoid this, we need to add or stuff one single bit instead of one byte to prevent the pattern from looking like a flag. So in the byte protocol, we used one byte as escape character in between the data wherever we see it as a flag, and here we are using single bit to prevent the pattern looking like as a flag. So in this strategy is called bit stuffing. There we are stuffing the byte and here we are stuffing the bit. So in bit stuffing, if a 0 and 5 consecutive bits are encountered, one extra 0 is added. So this extra stuffed bit is eventually removed from the data by the receiver, and the note that the extra bit is added after 1 0 followed by 5 ones regardless of the next value. So this guarantees the flag field sequence does not inadvertently appears in the frame. So this figure you can use for the exam to represent how this framing happened. There is flag at the beginning and end of the frame, and this is 0 1 1 1 1 0, and next thing the data and the header and trailer. So the figure shows the bit stuffing and unstuffing. If you see in this figure, they are using the data, okay, the data from the upper layer. If we see, there is a single 0 and 3 zeros and 5 ones, and what happened, if it look like a flag, so what they did, they have added 1 0 after the 0 and 5 ones, and again there is 5 ones, 0 and 5 ones, they added one extra bit. So these 2 extra bits are added in stepward in between the data to remove the inconsistencies, or if the receiver can take it as a end of the frame, to remove that they have added extra 2 bits. And this is the frame sent from the sender, and once the frame is received, these 2 extra bits are being unstuffed and these data is shared to upper layer also. So this is the diagram for bit stuffing and unstuffing. This is very important. Add this when we are writing the exam. So this activity or this solution will keep the sender or receiver to acknowledge the exact data that were sent by the sender, and it will receive the same data that is sent by sender. So this is all about framing. So this is a 10-mark question repeatedly asked in the public exam for KTU, computer communication. So please study this one. It is very important question. So thank you for watching my video. If you like this video, please subscribe my channel, and if you have any doubt regarding any topic on computer communication ECE 407, please let me know and put the same in the comment box, and I will definitely put the video as soon as possible. And thank you for watching my video. Please subscribe my channel, like, share and comment. Thank you. See you in the next section.